Hello everyone, I'm Dongfang Wang from Beijing Normal University in China. It's my great honor to be able to attend this meeting. Today I would like to present my research on covering urban energy-water line nexus within a multi-scale economy, a case study of 4 megacities in China. It will cover the following 4 aspects. First, introduce some background and the goal about this research. Second, methodology. There are some results will be shown, and last, some conclusions we have got. First, the background of this research. The development of urbanization and industrial made more and more people live in urban areas. Cities play an indispensable role in the sustainable development strategies, although they are powerhouses of economic growth, contributing about 60% of global GDP. By 2010, the number of megacities was 27. The population they contained grew to 460 million, accounted for 6.7% of the world's population. Water, energy, and land are essential for many life-supporting functions and key for satisfying basic human needs and development. Access to these resources and their sustainable ecological management are the basis for sustainable development. Cities occupy less than 5% of the Earth's land surfaces, but contribute to 60 to 80% of global energy and 26% of the fresh water. Due to the interconnectedness of the energy-water land subsystems and the complexity of an open urban system, it is essential to take a nexus view to identify trade-offs not only within local supply chains but also across regional, national, or even global supply chains. Currently, the conceptual framework of urban food energy water nexus can be summarized from 3 perspectives, namely resource interdependency, resource provision, and system integration. The purpose of this research tries to deeply understand the reasons for the formation of the characteristics of urban energy water line flow patterns within the multi-scale economies. In order to achieve our goal, we need to solve the following questions. First, what were the general characteristics of energy water land in the 4 megacities? Second, what were industrial structure characteristics of energy water land in the 4 megacities? And last, what were the key industrial sectors? Thus, we use the environmental extended multi-scale input-output model to analyze the urban energy, water, and land resources. X is the total output, I is the identity matrix, and A is the direct requirement coefficient matrix, and L is the Leontief inverse. F represents the embodied environmental impacts. E is the environmental satellite accounts. In our research, it identified as energy, water, and land use. We calculated the embodied environmental impacts as the second equation. Detailed methods can be found in our latest research. In the EE-MSI model, we divided the area into 17 aggregated regions as shown in Table 2, and 7 aggregated economic sectors for each region were considered as shown in Table 3. We analyze our data from 2 approaches, the production-based accounting and the consumption-based accounting. The PBA can account for the resource flows embodied in products produced locally and distinguish its destination for local consumption, domestic exports, and foreign exports. The CBA can account for the resource flows embodied in products consumed locally and distinguish its origins for local production, domestic imports, and foreign imports. The environmental satellite accounts used in this study include 3 types of data: energy consumption, water consumption, and land use. For sectors in China, data sources are as follows. Energy consumption only includes that used for production purpose. They were from National Energy Statistical Yearbook. Water consumption data for the agriculture sector were estimated based on the consumption of water footprint. We considered green and blue water but excluded green water. Water consumption data for the industrial and service sectors were from China's statistical yearbooks. Land use data were from the China Statistical Yearbook. This data for sectors in foreign countries were obtained from the WIOD. We introduced the data processing in detail in our study. General nexus analysis of energy, water, and land. As the figure 1 showed, that all four megacities were consumption-oriented cities for energy, water, and land resources. Nearly 72 to 77%, 87 to 92%, and 95 to 99% of the consumption-based energy, water, and land flows were sourced from outside the geographical boundaries of Beijing, Tianjin, and Shanghai, respectively. Domestic regions were the major suppliers for the four megacities. We know the general characteristics of the energy, water, and land nexus. Then we need to deeply know the reason from the sectoral perspective. The two largest shares of production-based energy flows can be attributed to the electricity, gas, and water, and the other sectors of the four megacities. The two largest shares of consumption-based energy flows can be attributed to the construction and the other sectors in Tianjin, Shanghai, and Chongqing. Beijing showed quite different sectoral structures of consumption-based energy flows, where the service sectors occupy the main position, followed by the construction sector. Local and domestic regions accounted for the leading position from the production and consumption-based energy flows of the two main sectors. The electricity, gas, and water sector was dominant in Shanghai, while the agriculture accounted for the largest share in the other three megacities from the production-based accounting. In Beijing, the services sectors had the largest share of consumption-based water flows. From the consumption-based accounting, the agriculture, food, and services sectors accounted for the largest share. In the rest of the three megacities, local and domestic regions accounted for the leading position from the production and consumption-based water flows of the two main sectors. The agriculture sector was a critical land consumer for the four megacities, accounting for more than 17% of each megacity's production-based land flows. In Beijing, the services sector was the largest one, accounting for 37% of consumption-based land flows, followed by the agriculture sector. While in the other three megacities, agriculture and the food sectors were the main land contributors. Local and domestic regions accounted for the leading position from the production and consumption-based land flows of the two main sectors. Cross-sectoral energy, water, and land nexus of key sectors can help to explain urban industrial characteristics within the boundary. For energy, more than 13% of the electricity, gas, and water sector and 23% of the other sectors consumed by sector self. For water, more than 25% of the agriculture sector and 59% of the electricity, gas, and water sector consumed by sector self. For land, more than 50% of the agriculture sector consumed by sector self. The four megacities were consumption-oriented cities, and the outside boundaries were the leading suppliers. Therefore, transboundary analysis can help to identify the source and destination of critical sectors at the regional level. For energy, the electricity, gas, and water services and other sectors imported the large energy flows from the domestic and international regions. The central and northwest were the main supporters. For water, the agriculture and food sector imported the largest water flows from the domestic and international regions. The central and southwest were the main supporters. For land, the agriculture and food sector imported the largest water flows from both the domestic and international regions. Northwest and southwest was the main supporters. Through results of analysis, we can draw the following conclusions. First, we need to change our thinking from silo thinking to nexus thinking. The traditional urban ecology management mode often focuses on one single environmental or ecological element within its corresponding administrative department, while the nexus thinking depicted the complexity and interconnected of multi-elements within cities and across regional, national, or even global supply chains. Second, changing consumption patterns. The adjustment of consumption patterns at sectoral level is extremely important for cities, especially for megacities. Third, urban should co-transboundary energy, water, and land nexus management, strengthen domestic inter-regional trade cooperation is a potential solution to ease the pressure on resource supply. For foreign regions, countries can develop related industry according to their competitive advantage, thus promoting international industrial division and cooperation and promoting the development of the regional economy. Coordinated management, which can help cities rethink urban ecosystems and ensure that they are greener, efficient, resilient, and more equitable. For future research directions, more ecological elements such as nitrogen, phosphorus, and other elements could be considered if the data available to obtain. An urban energy, water, and land visualization toolbox or website should be developed, including specific destinations and sources within local, regional, and global scales. It is necessary to present multi ecological element flow patterns and analysis typical indicators. It can serve as the practical tool for urban decision makers. Network analysis of urban industrial sectors is a research trend. Okay, that's all about my presentation. It has been my pleasure to give you my viewpoint on uncovering urban energy water land nexus within a multi-scale economy, a case study of 4 megacities in China. Thank you very much.